Hello everybody, and welcome to exercise 2A on page 139 of the workbook. This is another example of calculating first partial derivatives of a function. This time the functions are a little bit more complicated than in the previous video. Alright, so let's look at part A together here. They're giving us a function that looks like f of xy equals y to the xy. And they'd like us just to calculate the derivative with respect to x and with respect to y. All right, so let's start with the derivative with respect to x. Okay, and notationally, we could write that down as partial x of y to the xy. Okay, when you look at that, you might notice that there's a product of two things, y times e to the xy, so you might think we need a product rule here. And you could use the product rule, but there's a shorter way if you remember that we're treating y as if it's a constant. In this problem, x is our variable, and so this y that you see out front is a constant that can be pulled out of the derivative. So I'd like to do that before we start taking derivatives, because that's going to make this problem easier, making that observation. Okay, so really all we need to take the derivative of then is e to the xy. Okay, what kind of a derivative is involved? Okay, what derivative rule do we need to tackle that? Okay, well, you might recognize this as a chain rule, okay, where the u is the xy. We're trying to take the derivative of e to the u here. So we're going to get y, and then the derivative of e to a power is just e to that power. And the chain rule says we need to still multiply by the derivative of the u part. Okay, so we're going to get y to the xy times the derivative of xy with respect to x. Okay, so we've got one more derivative that we need to take. Let's recopy the part of the problem that we're done with, y to the xy. And then this xy, remember again that we're treating y as if it's a constant. And so we can pull that y out, and all that's left to take the derivative of then is x. So we've boiled this entire problem down to just one derivative, and the derivative of x is 1. And so our final answer is going to look like this, which we could simplify if we want to down to y squared e to the xy. We're just taking the two y's that you see there and moving them to the front and consolidating. Okay, and so there is one of our two partial derivatives. So what about the derivative with respect to y then? Okay, well this time we're trying to take the derivative with respect to y of our whole function. And in this case, you might notice that we're treating the y as if it's a variable, so here we can't factor the y out like we did in the part above, because y is a variable and e to the xy also has y's in it. So here, we really don't have a choice. We do need to use the product rule on this. Okay, and let's recall the product rule together. It sounds like the first function times the derivative of the second plus the second function times the derivative of the first. Okay, and just for the sake of your notes, let's remind ourselves that this was the product rule that we used here. Okay, and so continuing with this, we've got a couple of derivatives that we need to take, so let's recopy the y, and then we need to take the derivative of e to the xy. That's going to be a chain rule again. So the derivative of e to the u is e to the u times the derivative of the u. Okay, and then we move over, and we've got an e to the xy, and then we need to take the derivative of y, but that's just going to be 1. Okay, almost there. We've just got one more derivative to take. Okay, that one right there. So we'll recopy the y to the xy that we're done with. And what would the derivative of xy with respect to y be? Okay, well, x is a constant, so we can pull it outside. And then all we have to do is take the derivative of the y, which is going to be 1. Right, so looks like we're going to get that. And over here we've got e to the xy times 1, which is just e to the xy. And so putting it all together and just rewriting this, I'm going to take this x and just move it to the front. Right, this is xy e to the xy plus e to the xy. And that should be our answer. okay, for the partial derivative with respect to y.